Today, I'm giving ELEGOO another chance to impress me with the Neptune 3 Max as I finally retire my decade-old living room speakers to showcase what is possible when you combine 3D printing and CNC machining. This is the Neptune 3 Max. There are many like it, in fact, this is my second one to date. Here's a bench sheet printed with the stock 0.4mm nozzle, and this is also where we part with that caliber. Suffice it to say, the machine boasts a 3 cubic foot build volume, which at 0.2-ish mm per layer would take months to populate. So here's a 0.6mm nozzle, and with a few tweaks in the slicer, I managed to dial in a starting profile. This is how the machine will remain configured, and with a 420 by 420mm build surface, I can easily crank out something like this half-meter long spacer jig. It'll come in handy later on, though before going over the feature build, perhaps a little context. Right away, this box has traveled here all the way from Ukraine, and with the contents wrapped very much the way that I would package something handmade for a personal client. These are the Verum ones. An incredible show of the enduring maker spirit, with the guy making this in a bomb shelter, so quite the conversation piece for anyone with a stance on foreign politics, or even race, as I'm told. Personally, I like headphones for the fact that I can put them on my head and listen to them, which I did, immediately noticing the hidden potential. As the mini DSP ears confirmed shortly thereafter, the massive 82mm drivers remain linear from the very bottom, clear across the mid-range, making for a very simple set of corrections. And it's precisely the manner in which these unusual 8-ohm planars respond to such corrections that makes the headphones sound f***ing incredible, with about as wide a soundstage as I'd ever experienced, and detail retrieval completely destroying my M1060s. Properly equalized, they even wowed Sophie to tears, but my personal takeaway here is that I want that kind of sound in my living room. I have stacks of NDAs from projects involving speakers that cost a small fortune, the kinds of contraptions that most people only ever get to hear at an audiophile expo. And with the Carbide 3D setup in the garage, I am clearly out of excuses for not building an esoterically high-end set of speakers for my own listening space. So, let's talk acoustics. Right away, the biggest challenge when it comes to detail retrieval in an enclosed space is the distance that we put between ourselves and the sound source, with the ratio of direct to reverberant pressure waves degrading as we recess the speakers away into the corners. Let's say, for instance, that this phone screen represents a conventional speaker and that up close it resolves plenty of detail. However, as we go to move it away and the boundary effect diminishes, the nuance goes away as well. With speakers, the conventional wisdom is to simply turn it up, effectively compensating for the inverse square law, which, as you can see with the phone screen analogy, doesn't actually restore any of that closeness or any of the detail. It simply makes the distant source more intense, simultaneously pelting the adjacent walls with the sum of that intensity, further conflating the original sound with how the room reacts to it. This, by the way, is what breaks the illusion of a three-dimensional soundstage, inadvertently making the listener aware of the speaker's distance and location. However, in keeping with the optical analogy, one way to actually restore the detail would be to magnify the source in the direction of the observer without blaring the screen, as it were, or in this case, making the piston move a lot. In fact, there is a direct relationship between excursion and distortion, even within bounds of what is considered linear operation. And to magnify things acoustically, we can employ horn loading. So, what I've done here is model an exponential waveguide, loading a set of compression drivers down to about 500 Hz with around 10 decibels of purely acoustic gain. This will transform even the faintest vibration of the diaphragm into a very fast, high-amplitude directional wavefront so that power can be used for dynamics rather than overcoming distance, kind of like with headphones. Below that, a single 5-inch extended range driver from Tangband will cover the lower register. Once again, horn loaded, and I'm tapping in about 57 cm past the throat to help mitigate this resonant mode. What follows is another 2 meters of expansion, at the end of which the back wave is large enough to couple with the corner, which then becomes the final segment of the horn, effectively making the room a part of the enclosure. This loads the piston down to about 30 Hz, and with no compression chambers anywhere in the system, the transient response across the entire system is free of mechanical capacitance and therefore lightning fast. Speaking of Illumination, all the RGB functionality will be handled with 6 microcontrollers in 3 separate light zones, but more on that as we get into the build. Right now, I just want to make sure that this will in fact work. For whatever reason, I hadn't actually seen anyone try it. So here is a simplified form of the exponential geometry that I'll use in the final design. This one stops short of any drastic overhangs and relies on thinner walls with a bit of infill. Either way, it absolutely works and right as expected. In fact, just for a silly comparison, I wired the compression driver into the existing tweeter. And what I've done is hooked it up to the tweeter channel back there. It's still unplugged by this wire, as you can see, but it is being fed the same signal that this tweeter is being fed. So what I'm going to do now is simply plug it in so the two run in parallel.
Okay.
Now bear in mind, this is 108 decibel sensitivity, whereas this I believe is 98-ish. Alright. Now for this. What do you think?
It's actually really impressive. Here. Come switching spots.
Next, again, just to f with the printer, I decided to conduct an overhang test by extending the exponential curve out past the 50-degree mark and just letting it fail whatever. This taught me a lot about varying the print speed and the filament flow as the extruder nears the upper rim. Needless to say, making this happen without any supports will be an exercise in patience. Right away, the final design avoids overhangs in excess of 45 degrees entirely and comes together in two nearly 100% solid parts, extending the exponential geometry out to where the edge diffraction doesn't interfere with the wavefront and when you're as much as a conventional tweeter in a conventional baffle. And if you're put off by the print taking 100 some odd hours to finish, consider instead what else could be done in that time, sort of like a race against yourself. Case in point, by the time that I'm snapping this off of the build plate, I'd like a fancy set of side tables. For the longest time, I've been using these adjustable stands, literally standing in for the various surfaces I imagined I'd want around the couch. And now, with a CNC machine in the next room, it's just a matter of jotting those ideas down in CAD, setting up a few toolpaths, and watching the thing zip around. Also, with the Neptune 3 Max already working on the horn, I enlisted the Neptune 3 Plus from an earlier video to make all the fittings at a 0.2mm layer height using the stock nozzle. I'll spare you the extended montage, suffice it to say we got everything assembled, and see, I'm using the thing. Got it painted, some illumination, some cable management, and just in time towards the horn emerge complete. Well, that piece anyhow. What's more, a properly crafted one of these will fetch upwards of $1,000 on the open market, making the 2 rolls of filament I just ran through seem like a meager expense. Here's the bezel, completed in about 33 hours, and here's Sophie applying some JB weld to the outer rim. That comes together like so, and there it stays with a 10-pound weight. Now I get to do the other one. So either that's another 100+ hours of Are We There Yet? Or maybe we have a look at the brand new Neptune 4 series, at least the Pro. It's just a question of where. And with the presentation table occupied, it's right back to the Carbide 3D corner for more impromptu cuts, pilot holes, insets, really everything is just click of a mouse now. But if there's one thing that 3D printing has gotten me good at, it is retrofitting, and I'm about to make this wire rack into something of a modular workbench with interchangeable panels. Some 3D printed grommets, a pad, that'll work, and with time to spare. So here's Sophie on the final stretch with that exo height finish, and with the print still going, the workbench is ready. Here's the start of the second bezel, and that's plenty of time to see what's new with the 4 series. Right away, the Pro features a 225 by 225mm segmented heat bed, a high temperature dual gear direct drive extruder, and this massive blower, allowing it to print at upwards of 500mm per second. The interface runs on Clipper with a 64-bit quad-core processor, though most important of all, there is finally a light at the hot end. Here's a 40-minute benchy, and apart from some very minor artifacts, this is looking really good. In fact, by the time the second horn came together, I was already on version 2 of my wire grommets, this time making them interchangeable without anything having to be unplugged. Anyway, I think we're all set to begin on the lower frequency horn, which brings us back into the garage. And just in time for Carbide 3D to set me up with one of these extended bass upgrades for the Sweepy 2.0 dust put. This one is meant for use with the VFD spindle, but to me, the selling point is the curve along this elbow, which dramatically improves the airflow and with a lot less sucking noise. Anyhow, to save on time and cost with this build, I decided to stack fabricate only the curves, then, if need be, plane down any excess. There's also a bit of internal cable management. These channels will conceal a series of RGB data lines, in addition to the speaker cable, each confined to its own sealed-off pathway leading rearward. There, a 3D printed junction panel will be fitted with a set of RGB controllers, and here's the Neptune 4 Pro laying it out at speed, doing a bang-up job. The supports release with minimal effort, and then it's on to the other one. The two front panels will call for some double-sided 3D machining. Hadn't tried that yet, so here goes nothing. I'm literally just carving out an STL file. Here's the rough pass with the end mill, and the finishing pass with the ball end, still looking a tad corduroy. This, by the way, is where I learned about the default step-over distance. Thankfully, as long as the machine retains its coordinates, I can halt the entire operation, revise it, and continue from the point of the revision. In this case, a second finishing pass with a much smaller step-over. This was followed by a series of vector-based toolpaths, just to ensure that all the dimension-critical features are the correct shape and exactly where they are supposed to be. Finally, an outer trace with tabs, and we are looking good. So I'll just move this thing over a bit and run the whole operation from the top. Afterwards, on the opposite side, a few more pocketing operations for the electronics, and getting it all to align is literally as simple as homing to the origin. As long as the cutter knows where it is, the machine remains incredibly precise. Now then, in terms of assembly, I could either build the stacked portion up a layer at a time, with all the internal panels already in place, or I could assemble the stacks separately, then attach them to the side panel, then add the internal panels. So I did it both ways, and the second approach suits me better. Up next, a bit of prep before the sanding sealer, followed by a few coats of the water-based stuff from Minwax, followed by some enamel for the front and the sides, and then some brush on exohide everywhere else. This is where I wire in the electronics, namely a series of high-density RGB IC strips, each controlled by its own ESP8266 module, which I flashed with some firmware for easy control over the individual LEDs. These wire into the 3D printed junction panels, and with everything thoroughly blue-tacked, the seal is airtight. Now, before we get too far along, let me just apply power and... yep, those are working. Although the voice control over the Amazon Echo leaves a lot to be desired. The accent panels are fitted with this mirror backing to redirect the light, and once I got the compression drivers onto the upper frequency horns, the last couple of bolts sealed the deal. This is where we discuss the amplifier stage, and in keeping with my routine of a new feature build, anytime I unbox a new machine, the Neptune 4 will help me prototype something I've been thinking about. I would like a minimalist 4-channel amplifier made specifically for driving a pair of two-way speakers. No power switches, no volume knobs, just a pair of line-level inputs, some DSP functionality, and 2 sets of outputs. One set for the highs, one set for the lows. Take notes, Dayton Audio, because I'm using your stuff for the guts, namely this 4x30W amplifier board and a multi-purpose DSP programmer. Everything appears to align against the rough draft sliced with ELEGOO's extra fast profile, so now let's up the quality for the final rendition. Unfortunately, the build sheets that these machines come with have a tendency to release the corners of larger, rectangular models, and this is evident with each reprint. So, as a matter of full disclosure, the amplifier shell that I am now populating was not printed on an ELEGOO machine. At this point, I'm simply moving the video along because once I got all this bullshit wired in, I decided to make the top out of clear acrylic. After all, who needs a power on indicator when there's already so many LEDs on all the internal components? That plus it's my first time using this spring-loaded diamond-coated drag engraving bit called the MC Etcher. By the way, there's also T's nuts. No? Well. Anyway, as you can see, there is no spin and the bit is literally just scratching in some graphics. 4 screws later, I have a companion amplifier for the speakers, and a companion of my own, already enamored with the sound, even with just the DSP crossovers enabled, to say nothing of the fact that the speakers aren't actually in place. So, out with the old, in with the new, that whole business, and there is a lot of nonsense here that my tiny amplifier does away with. There's a couple of the old Dayton DTA 100s, each with its own charger brick, a mini DSP 4x2, and all the patch cords in between. The initial frequency sweep revealed something very close to my target listening curve, requiring only a minor downward nudge around 100Hz and a slight boost around 500Hz. Yet, while the 20 or so watts per driver is enough to vibrate all the fixtures in the house, hyper-efficiency is a double-edged sword. Namely, with a signal-to-noise ratio in the mid-90s, the amplifier's background hiss alone carries across the open space with unforgiving clarity. So here's plan B. Also a 4-channel amplifier raising the headroom by about 20 watts per channel, but more importantly, with a signal-to-noise ratio of 100 decibels. Its only irredeemable flaw is the operating noise, with the culprits located here and here. Thankfully, I came prepared with some upgrades from Noctua, so with the silent fans in place, it's right back to the mini DSP, and that's been the configuration ever since. There will be a demo at the end, however, to showcase what these speakers are capable of, I can't very well just run through a handful of my own tracks. So, at the risk of having this video be demonetized, I will feature some copyrighted content. Truth be told, these types of presentations don't earn a lot of YouTube revenue in the first place. We're talking maybe a couple $100 over the span of a year. So it won't break my heart to see this number drop to 0 on a single video if it also means that I get to share something relatable. That's coming up here in just a moment, so go grab the good headphones. In the meantime, big thanks go out to ELEGOO for sending out the machines. The Neptune 3 Max is probably as big as you'd ever want a bed slinger to get, and with a large enough nozzle, the build volume begins to make sense. The Neptune 4 is a good desktop companion. It's fast, it's well suited for smaller prints, and with no shortage of readily available aftermarket build plates or heated enclosures to help with lifting edges on larger prints. The Verum ones, despite their overall low impedance, appreciate a bit of power, and with a few simple DSP corrections, both the sound and the staging becomes exceptional. Speaking of which, for today's demo I'll be recording at the listening position, and just to convey how well the horns project into the room, a second field recorder will be set up about 20 feet away. So feel free to chime in with the particulars of your listening setup, rate the video as you see fit, subscribe if you're so inclined, and I'll see you in the next one. Cheers! You can really hear the room in that one, the recorded one. That bass over there.
Recognize the fracture line it has. How bad's the pain? The city's feeling worse than ever. Can't you make it go away? He stays.
The bass dry enough? Yeah.
Let me take you home. I let you down. Let me climb up you to the top so I can see the view from up there. I'm floating down
side like you do for you.
You can only imagine when the one back there is recording.
Imagination calling beers for you. Hey now. Hey now. A na razie fruwają motyle. Tyle tego, tamtego też tyle. A na razie wierzymy właśnie. Jaśniej, a na razie kołyszą nas noce, a na razie kołyszą nas dni. Choć już życiem siadać popołudnie, jest cudnie, jest cudnie.
So what are your general thoughts on clarity?
You know, when you get out of the shower and you're like, you got water, you take that moment to actually Q-tip yourself.
Yeah.
And then you yawn and you hear the click and everything sounds right.
It's a good way of putting it, I guess.
It's spiffy shit.
It's the other playlist. This is really well recorded.
Button your lip and don't let the shield slip. Take a fresh grip on your bulletproof mask. And if they try to break down your disguise with their questions, you can hide, hide, hide. Behind paranoid eyes.
There used to be a grand tower alone on the sea. You became the light on the dark side of me. Love remains a drug that's high enough to heal. But did you know that when it snows, my eyes become alive and the light that you shine can't be seen?
This intro is also really recorded. Real enough?
That's good, dude.
mid-range of this in the coach.